students, so here we are with the question first of the exercise 2.4 of the chapter Polynomials. So the question first is, verify that the numbers given alongside of the cubic polynomials below are their zeros. Also verify the relationship between the zeros and the coefficients in each case. And we have been provided with the two parts A and B. So now let us come to the first part, that is A part. Here the polynomial given is 2x cubed plus x square minus 5x plus 2. And the three numbers being provided are 1 by 2, 1 and minus 2. What we need to verify first is that whether or not these three numbers are the zeros of the polynomial given. So in order to find whether or not these are the zeros of this polynomial, we will substitute each value in this polynomial one by one. So now let us start with the value or with the number 1 by 2. Now putting the value 1 by 2 in place of the value x in the polynomial, we will write the polynomial as 2 into 1 by 2 cube plus 1 by 2 square minus 5 into 1 by 2 plus 2. So now doing the mathematical calculation, this term comes out to be 2 by 8 plus 1 by 4 minus 5 by 2 and plus 2. So the value of this terms comes out to be 0. And as on substituting the number 1 by 2 in the polynomial, the value comes out to be equal to 0, which means that 1 by 2 is a 0 of this polynomial. Now coming to the second number, that is 1. Now substituting the number 1 in place of x in the polynomial, we will obtain minus 5 into 1 plus 2, or we can write it as 2 plus 1 minus 5 plus 2, which comes out to be equal to 0. What it means is that 1 is a 0 of this polynomial. Now coming to the third number, that is 1 by 2. The third number is minus 2. Now substituting the value minus 2 in place of x of the polynomial, we will obtain 2 into minus 2 cube minus 2 square minus 5 into 2 minus 2 and plus 2. Okay. Or we can write it as minus 16 plus 4 plus 10 plus 2, which comes out to be equal to 0. So what it means is that therefore minus 2 is a 0 of this polynomial. Now let us do the verification part. Before proceeding to the verification part, we have to write the values of A, B, C, D, alpha, beta and gamma respectively. So the value of alpha A is equals to the value of the coefficient for x raised power cube. That is, A is equals to 2. B is equals to the coefficient of the x square. That is, it's b equal to 1 in this case. C is equals to the coefficient of x. That is, C is equals to minus 5. And D is equals to the constant term in the polynomial. So here D comes out to be equal to 2. Alpha, beta and gamma are the three zeros of this polynomial. So the three zeros of this polynomial are 1 by 2, 1 and minus 2. So let us take alpha be equal to 1 by 2 beta be equal to 1 and gamma be equal to minus 2. So now coming to the first part of the verification. So in first part of the verification, we will verify whether or no the sum of the zeros comes out to be equal to minus b over a. So alpha plus beta plus gamma is equals to 1 by 2 plus 1 minus 2, which comes out to be equal to minus 1 by 2, which is exactly equal to minus b by a. As b value is equals to 1 and a value is equals to 2, so means minus b over a is equals to minus 1 by 2. So this relationship has been verified. So now coming to the second relationship, what it says, alpha into beta plus beta into gamma plus alpha into gamma will be equal to c over a. First of all, let us substitute the value of alpha, beta and gamma in this relation. So substituting the values, what we will obtain is 1 into minus 2 plus minus 2 into 1 by 2. Or we can write it as 1 by 2 minus 2 minus 1, which comes out to be equal to 1 by 2 minus 3, or is equals to minus 5 over 2. As 5 is equals to, minus 5 is equals to c, so we can write here in the numerator c, and a is equals to 2, so we can write a in place of 2. So as alpha into beta plus beta into gamma plus alpha into gamma is equals to c over a, which means that second relationship has also been verified. So now coming to the third relation says the product of alpha, beta and gamma is equals to minus d over a. Now substituting the values, that is 1 by 2 into 1 into minus 2 comes out to be equal to minus 1, and as we know d is equals to 2 and a is equals to 2, on dividing d over a, the answer comes out to be 1. So we can write here minus 1 be equal to minus d over a. As the third relationship has also been verified, which means that the values of a, b, c, d, alpha, beta and gamma satisfy all the three relationships, and the numbers provided are the zeros of the polynomial given in a part. So this was about the a part of this question. Now coming to the b part of this question, here the polynomial provided is x cube minus 4x square plus 5x minus 2, and the three numbers being provided are 2, 1 and 1. So writing it over here, that is x cube minus 4x square plus 5x minus 2, and the three numbers being provided are 2, 1 and 1. So in order to verify whether or no these are the zeros of this polynomial, we will substitute the value, or we can say we will substitute the number 2 and 1 in the polynomial 1 by 1. So substituting the first number, that is 2, in the polynomial, we will obtain 2 cube minus 4 into 2 square plus 5 into 2 minus 2, or we can write it as 8 minus 16 plus 10 minus 2, which comes out to be equal to 0. What it means is that as the value of this polynomial, on substituting in place of x, the number 2 comes out to be equal to 0. Therefore, 2 is a 0, because its value comes out to be equal to 0 on substitution of number 2 in the polynomial. Now coming to the second number, that is 1. So on substituting this in the polynomial number 1, we will obtain plus 5 into 1 minus 2, or we can write it as 1 minus 4 plus 5 minus 2, whose value comes out to be equal to 0, which means therefore 1 is a 0, because on substituting 1 in the polynomial, its answer comes out to be equal to 0. So as the third number is the same as that of the second number, which means that 1 is a 0. So it has 2 zeros equal to 1. Now coming to the verification part. So for the verification part, first what step we will do is to find the value of A, B, C, D, alpha, beta and gamma. The value of A is equals to 1, that is, which is equals to the coefficient of x cube. B is equals to minus 4, which is the coefficient of x square. C value is equals to 5, which is the coefficient of x. And D is a constant, that is minus 2 in the polynomial. And alpha, beta and gamma are the 3 zeros of the polynomial. Let alpha be equal to 2, beta be equal to 1 and gamma be equal to 1. So now coming to the first relation for the verification, what the first relation says, the sum of all the 3 zeros equal to minus b over a, that is alpha plus beta plus gamma is equals to minus b over a, or no? If yes, then the relation is satisfied. If no, then the relation is not satisfied. So substituting the value of alpha, beta and gamma in this, that is 2 plus 1 plus 1, which comes out to be equal to 4, which can be written in the form minus b over a. So as the sum of the 3 zeros comes out to be equal to minus b over a, which means that the first relation has been satisfied. Now coming to the second relation, what it says, the product of the alpha into beta plus beta into gamma plus alpha into gamma. On substituting the values of alpha, beta and gamma in this relation, we will obtain 2 into 1 plus 1 into 1 plus 1 into 2, or which is equal to 2 plus 1 plus 2 is equals to 5, which can be written in the form c over a. As the value of c is equals to 5 and a is equals to 1, so 5 can be written in the form c over a, which means alpha into beta plus beta into gamma plus alpha into gamma comes out to be equal to c over a. So the second relation has also been satisfied. Now coming to the third relation, that is the product of alpha into beta into gamma, which comes out to be equal to 2 into 1 into 1 is equals to 2, which can be written in the form minus d over a, has also been satisfied, as we are able to write the relation alpha into beta into gamma in the form minus d over a. So the third relation is also perfectly fine for this polynomial, which means that we have verified that these 3 are the zeros of this polynomial and have also verified the 3 relationships between the values of a, b, c, d, alpha, beta and gamma respectively. So this was all about the question first of the exercise 2.4. I hope this question is clear to all of you.